Hi everyone. I think this is my first video for your class. So this is how I'm going to try to present lessons, and maybe we can also try to meet in a Google Hangout in case afterwards you have questions and I can answer them. All right, so we're still working with polynomials. You have been able to find the zeros, and I will post the homework solutions to all those problems so you can check them and ask questions. But for now, I'm just going to move on to the graphing. So when we graph polynomials, there's something called end behavior, and what that refers to is what the graph is doing, going to the left down to negative infinity and going to the right up to positive infinity. So we're going to look at very simple polynomials and use those to extend the end behavior to more complicated polynomials. So for example, if I look at a very simple one like y equals x squared, everybody knows what that looks like. It's a parabola, and it opens like this. So when you look at the ends, when I mean the end, that means here and here, you see it's going up on the left and up on the right. So we call this up, up, right? So in this situation, my exponent is even and my coefficient here in front of my x is positive. So my a is positive, and we're going to call that n for the exponent is even. So anytime I have a polynomial where a is positive and n is even, the end behavior is up, up. So conversely, if I have a simple even, sorry, I don't want to say even function, but an even degree that's negative like this, I know my graph's going to look like this, right? And in this case, this is down, down, right? It's going down on both sides. So the difference, though, is that this is still even, but here is negative, right? So now my a is less than 0, excuse me, and my n is still even. So anytime I have a polynomial where n is even and a is less than 0, my end behavior is going to be down, down. I'm using a very simplistic example of x squared because that's easy. You guys have seen that before and you recognize it. Now I want to look at when my exponent is odd, like 1, 3, 5, 7. So a very simple one is y equals x, right? Because that's to the first power. In this situation, my a is positive, right? Because the number in front of x is positive 1. And my n now is odd because it's an odd degree. So the graph of y equals x looks like this. So this is down on the left, right? And up on the right. So we call that down, up. And conversely, if I have y equals negative x, now a is negative and n is still odd. But I know the graph of that looks like this, and I know that's going to be up, down. So anytime I have a polynomial that has the leading coefficient negative and my n is an odd degree, it's going to be up, down. All right, so that is a summary of the leading coefficient and end behavior. Okay, let's move on to the next slide. Repeated zeros. So we know that if I have a factor of a polynomial, for example, if I have x squared plus 6x plus 9, I can factor that into x plus 3 times x plus 3, right? I know that x plus 3 is a factor, and I also know that negative 3 is a 0. But in this case, since x plus 3 appears twice, I could also write it like this. Since it appears twice, that means I have a repeated 0. Or in this case, we would say a double 0 because it's 2 times. So this is what this is saying here. So basically, if k, which is my exponent, if k is odd, then it's going to cross the x-axis because we need to understand how to draw it. And if k is even, it's going to touch, or we sometimes say bounce, off the x-axis. So in this case, since 2 is even, my graph would bounce at -3. I'm going to give you more examples. Sometimes, well, not sometimes, all the time for me. I'm a visual learner, so I need to see visually an example. So I'm going to show you right now. So we're going to take all of these steps here, and we're going to apply them so that we can graph a polynomial. So the first thing we're going to do is look at our polynomial, find the x-intercepts, right? And plot those. We're going to apply that end behavior leading coefficient test to see if it's up, up, down, down, up, down, down, up. We're going to determine if we have repeated zeros, and then we'll sketch the graph, okay? So the most important thing is this. These are just sketches, so focus on just the x-intercepts and the end behavior and the overall shape of the graph. I'm not going to be picky about how high or low that you're going, and I'll show you what I mean. Let's go to the next slide. So here's an example. I have a polynomial. I have 3 factors. And since it's already in factored form, it's easy for me to find the zeros, right? So my zeros are x equals -2, x equals 4, and x equals -7. Those are also called my x-intercepts, right? I also know it has 3 x's. So that means it's x to the 3rd. So my 3 is telling me it's an odd degree, so n is odd. And my a here, there's no negatives, so my a, there's no negative here in the front. So a is greater than 0. So that means my end behavior, if we go back to the other side, my end behavior was odd and positive. Odd and positive is this one. So it's going to be down, up. So I know it's going to be down, up, the end behavior. So the first thing I'm going to do is plot my zeros. So I have a 0 at -2. I have a 0 at 4. And 1 at -7. Okay? I know it's going to start down and it's going to end up, right? So all of these are to the, all of these are to the first power. So I have no repeated zeros. So when we look back at this slide, here, if k is odd, it's going to cross the x-axis, okay? So that means I'm going to start down, and I'm going to cross, I'm going to cross, and I'm going to cross. And that is how I do my graph. This part here and this part here, I'm not worried about. If I don't care how high or low you go, I care about the ends here and here. And I care about, are your zeros correct, your x-intercepts? And are you crossing or bouncing appropriately? So I just took all the information, I put it together to make my graph. Let me just fix my graph here because I feel like it's not accurate. All right, so my zeros were -2, -7, and 4. And I have to start down and end up, and I have to cross at each one. Cross, oop, cross, cross. You see I'm starting down here, and I ended up here. Okay, and that's all I had to do. Next one. See, notice now I have a 2 here, right? So I need to keep that in mind. My zeros are x equals -2, x equals 3, x equals 6. This is a double 0 because of that second, the exponent of 2. So I'm going to graph that differently. Remember, when the exponent is even, it bounces and it does instead of crosses, right? So let's plot our zeros. I have -2. I have +3 and +6. I have an exponent of 2 here. I have a 1 and a 1. That's n equal to 4. That means it's even. And I have no negative in the front, so a is positive. So even and positive is up, up. That means my graph is going to start up and it's going to end up. Now, at the -2 here, I have to bounce it. So that means it doesn't cross, it bounces off. So I'm going to show you what that means. At the 3 and the 6, since those are both to the first power, they're going to cross. So it's going to look like this. Bounce, cross, cross. So does everybody see the difference here? I had to bounce it because I have a even, and these two I crossed. And then that's my graph. Okay, I'll do one more because this has a negative now in front. So my A is less than 0. My original, my x is to the first power. This x minus 3 is to the third, and that's to the second. So when I add all those up, I have 1, 3, and 2. That's n equal to 6, right? Which is even. So if it's negative and even, that means it's down, down. Just like our negative x squared. My zeros are at 0 from here. X equals 3 and x equals 2. X equals 3 is a triple 0, so we have to graph that a little differently. It's going to cross, but it's going to cross a little different, and this is a double. So this is going to bounce. This is going to cross, but it's going to cross and linger. That's what happens when you have a third degree, and this one's going to cross. So I have to start down, I have to end down. Let me plot my zeros. I have a 0 at x equals 0. I have one at x equals 3. And then I have another one at x equals 2. This is going to be tight. So I have to start down. I have to cross at 0. I'm going to bounce off of the 2, and then I want to cross at 3. So what I'm going to do for this one is I'm going to change my my number line. I'm going to make this 1. I'm going to make this, hold on, just so it's easier to read. This is going to be a 1, 2, 3, 4, and we'll make this -1, -2, -3, -4, okay? Just so it's easier to plot. And so I have 0 here, I have 3, and I have 2. Okay, so I have to start down. I have to cross at 0. I'm going to bounce at 2, and I'm going to cross at 3 and linger. So I'm going to cross at the 0. I have to come here and bounce off the 2. And then I have to cross and linger. So at 3, because it's cubic, because it's third degree, I don't cross straight like it. You see how I cross straight for the 0? That's because it's to the first power. But when I have a third power, you see how it lingers here? So it doesn't cross directly. It sits on the x-axis a little bit. So those are pretty much all the different scenarios. There are 1, 2 more problems here. I'm going to ask you to try to do those 2 problems as practice, and you can submit those as a classwork assignment, okay? And if you have questions, please post them on Google Classroom. Thanks, everyone.